Okay, so in this video I'm going to pick back up where we left off going over the review for the first test. Questions 13 through 16 are solving equations. Through 17 are solving equations. They're all different types of equations, but we are going to solve equations. The first two are quadratic. I have an x squared, that's my highest variable. Those are quadratic equations. When you solve a quadratic equation, you want to factor everything that you can factor, or if you can't factor it, you need to use the quadratic formula. So the first thing that I do every time I see a quadratic is, can I factor it? If I can factor it, that's the easiest way to go. So what multiplies to negative 24 and adds to 5 would be positive 8 and negative 3. And then I just set each of those equal to 0, right? So x plus 8 equals 0, x minus 3 equals 0, and then I would get x equals negative 8, and x equals 3. Kind of the same thing with number 14. I would factor that into 2x plus 5 and 2x minus 5. And then I can set each of those equal to 0, and I would get essentially 2x equals negative 5, skipping a step here, 2x equals positive 5, divide by 2, x equals negative 5 over 2, and if I divide by 2 here, x equals positive 5 over 2. Okay, so for each one of those, if you wanted to use the quadratic formula, you absolutely could. What I like to do is, if I can't factor it right away, I'm not going to try to factor something that is really difficult to factor. Instead, I would just use the quadratic formula. Number 15 is a rational equation. With a rational equation, all you need to do is, step 1, get all your denominators to be the same. Okay, that's the first thing you want to do. Now, on this, you might look at this middle one and say, oh, I could just put a minus 1 with that, and then they would all be x minus 1. When you get common denominators, think about what you do with numbers when you get common denominators. You have to do multiplication to get common denominators. So I can't just say minus 1 because that's not allowed whenever I just use numbers, right? So if you had something like 2/3 minus 1/2, you can't just be like, oh, I can make this a 2 by subtracting 1 from it. You can't do that, right? So what I need to figure out is, what is my common denominator? What can I multiply each one by? So essentially, the ones that are x minus 1, I'm going to have to multiply them by x. The one that's x, I'm going to have to multiply by x minus 1. So what that would turn into is 2x over x times x minus 1 plus 3 times x minus 1 over x times x minus 1 equals 11x over x times x minus 1. Okay. Now all my denominators are the same. Once all your denominators are the same, you can essentially just completely ignore those. And we'll work with just the top here. So we've got 2x plus, I'm going to go ahead and distribute this 3. 3x minus 3 equals 11x. That means I'm going to get 5x minus 3 equals 11x. I would subtract the 5x over, so I'm going to get negative 3 equals 6x. And if I divide by the 6, I'm going to get negative 3 over 6, which is negative 1/2. And that is my final answer. Okay, so get all the denominators to be the same, and then just ignore them. Number 16 is a radical equation. I want to get rid of my square root. I do so by squaring both sides. I would get x plus 12 equals x squared. I then want to get everything equal to 0. I want to get it equal to 0 because I have a quadratic. So anytime you're solving a quadratic, you do want to get it equal to 0. I didn't mention that before. I like my x squared to be positive, so I'm going to move everything to the right side, but then I'm going to write that first. So I'm going to subtract the x, subtract the 12, bring those over to the right, but I'm going to write that first. So x squared minus x minus 12 equals 0. I now have a quadratic. My options are still the same. I can either use the quadratic formula to solve this, or I can factor if it factors. It does factor nicely. X minus 4, x plus 3. And then we'll set that equal to 0. So that means I'm going to get x equals 4 and x equals negative 3. The only time that you need to check your answers would be in this case. If you start with something that is not a quadratic equation, what we started with was not a quadratic equation, and then I ended up solving a quadratic equation, that's when you want to check. To check, just simply plug those in for x. If you plug in 4, I get the square root of 16 equals 4. That works. If I plug in -3, I get the square root of 9 equals -3, which is incorrect. The square root of 9 is just +3. So this is what we call an extraneous solution. The only answer is 4, and I need to cross out that -3 to indicate that that is not actually a solution. Number 17 is an absolute value equation. With an absolute value equation, you just take what is on the inside, and you're going to set that equal to both positive and negative, whatever this number is. A lot of people think they need to change the stuff in here. Do not change this stuff in here. Okay, so what we're saying when we do this is we're saying 2x minus 5 had better either equal 9 or -9, so that when I take the absolute value of that, I get 9. So just write it twice, one positive, one negative, and then just simply solve. Add 5, divide by 2. I would do that for both of these cases. If I add 5, I'm going to get 2x equals 14, so x is going to equal 7. And over here, if I add 5, 2x equals -4, so x would equal -2, and those are my two answers. Okay, that's all about equations. I realize there are a lot of different kinds of equations there. So you do need to make sure that you understand how to go about each one of those and how they look different. Numbers 18, 19, and 20 are all inequalities. I'll start with number 20. It's the easiest. If you just have an or inequality, that just simply means that I'm going to solve each of these separately. So just think of these as two separate problems. Here, add 4, I'd get 16. Divide by 2, x is less than 8. That's part of my answer. Here I would subtract the 3. I would have negative x is less than or equal to -10. And then I would need to divide by -1. And when I divide by -1, I need to make sure that I flip my inequality. And I'm going to get x is greater than or equal to 10. With inequalities, you are going to be expected to graph those. Here's 8, here's 10. 8 would be an open circle, and we want less than that, and 10 is a closed circle to the right. If you ever solve a compound inequality and the arrows go the same direction, you did something wrong. They should always either go away from each other, or you should be connecting them in the middle. So make sure that they're not both going the same direction. Okay, but that's it. We're done there. I do want to say that if it asks this question about interval notation, okay, if it asks the question about interval notation, and by the way, the graph part, if the graph is there, I expect you to graph it. If the graph is not there and it's not in the directions, I don't necessarily expect you to do that. But I do think that it's helpful when you're trying to write your answer in interval notation if you make the graph. Whenever you draw a number line, always just put negative infinity on the left and positive infinity on the right. And that's going to help you to write your intervals. So I need to write an interval for that part of the graph, which essentially every time you write an interval, you're just saying what's the left endpoint and what's the right endpoint. Well, the left endpoint of this would be negative infinity. The right endpoint of that interval would be 8, and because it's an open circle, or because I don't have or equal to, that's going to be a parenthesis. The u simply means and I have another part of my answer. The left endpoint of this interval would be 10, and I can include 10, so I use a bracket because it is a filled-in circle. The right endpoint of my answer would be positive infinity. Infinities always get parentheses, but that is my final answer there. Draw the number line. I do think it helps, especially if you put negative infinity and positive infinity on the number line. All right, I'm going to come back up to number 18. Number 18, just like number 17, it's absolute value, so I would just write it twice. And if it's the second one, I'm going to flip the sign and change this to negative. Now, I probably showed you a different way in the notes, which is totally fine, but some of you are possibly confused on when do I write it as an and inequality and when do I write it as an or inequality. If you just do this every time, you don't have to worry about that. So keep the first one exactly the same. For the second one, I'm going to say x minus 5 is greater than or equal to -3. Okay, so for the second one, I change both the sign, flip it, and I change it to a negative. And that just solved both of these. So I would get x is less than or equal to 8, and here I would get x is greater than or equal to 2 when I solve that. Now, if you graph those on the same graph, that's going to be what tells you if you have an and or an or inequality. Make sure you put the numbers in the correct order on the graph. But we have or equal to with 2, and it's greater than. So I would go to the right of 2. We have or equal to with 8, and it's less than. So I would go left of 8. And that means that my answers are between 2 and 8. So if I'm just trying to write what that interval would be, that interval would be 2, 8. And I would use brackets because both of those have filled in circles, and that would be my answer. Okay. If you liked it better, the other way to do it with less than, which is what I think I've shown in previous videos, is that you can just put the -3 on the other side and write it like this. If that makes more sense to you, do that. But if I do it this way and I just write it twice, and I remember for the second one I need to flip the inequality sign and make it negative, then it doesn't matter if I start with a less than or a greater than. I'm going to do that same task no matter what. Number 19 is also an inequality. It's quadratic. I would start this the same way I would do it as if it were an equation. I'm going to factor. What multiplies to -12 and adds to 4 would be +6 and -2. However, unlike an equation, I can't just say x plus 6 greater than 0, x minus 2 greater than 0, right? I can't do what I did up here for a quadratic where I just set each one of these equal to 0 and solve. I can't do that with an inequality. So here's the way I've shown in previous videos how to do this. And then I'm going to go to a graph and see if it makes sense when I do the graph for this as well. I'm going to make a number line. A number line always helps with inequalities. And again, if it helps, put negative infinity here and positive infinity here. If this were equal to 0, my zeros would be -6 and +2. I'm going to pick a number from each interval. So I'll pick something that's here. Anything that's less than -6. So let's say we pick -7. I'm going to imagine plugging that in for these x's. If I plug in -7, -7 plus 6 is a negative number. And -7 minus 2 is also a negative number. And if I multiply two negatives together, which is what's happening here, multiplication, then I get a positive number. And I'm going to do that with every single one of these intervals. So if I pick something between -6 and +2, like 0. 0 plus 6 is positive, 0 minus 2 is negative. Multiply those together, I get a negative number. And pick something greater than 2, like 3. 3 plus 6 is positive. 3 minus 2 is also positive. Multiplying two positives gives me a positive. After you make that number line and you go through that process, the question is, what was the inequality? The inequality was greater than 0. So I want the places where we had positive numbers, because positive numbers are bigger than 0. Negative numbers are less than 0. So I want this interval and I want this interval. And that means I just need to go through and say, well, what would that interval on the left be? That would be negative infinity to -6. I don't include -6 because I don't have or equal to here. And then I would also do 2 to positive infinity, and those would be my two intervals where my solutions would exist. On Desmos, without putting in the inequality part of that, if I did x squared, I believe it's plus 4x and minus 12. The -6 and the 2, those are the places where it equals 0. You should know that if you're looking for where something equals 0, you're looking for where the graph crosses the x-axis. So the question with this inequality was, when is it greater than 0? Which means, over what x interval is the graph above the x-axis? Well, that is over here. Anything left of -6 would be above the x-axis, or anything to the right of +2 would be above the x-axis. So keep that in mind. If you know what that graph does, it's just a parabola, and that's what the plus minus plus tells us. The plus minus plus is simply just a visual for what this graph is doing. And if that makes sense, you can get the intervals from that. If you want to make this number line every time, just know that you cannot go about this the same way you do a quadratic equation. It is different. Okay, last three questions here deal with lines. Number 21 is to find the equation of a line. The first thing you should do is find your slope. Y2 minus y1 over x2 minus x1. That is our slope formula. That's going to give us 2 over 3. So that's going to be my slope. And then once we have our slope, the way that I do this, I know that some teachers show this differently, but I now know if I'm doing slope-intercept form, I've got y equals 2/3 x plus b. I just have to figure out what b is. I can take either one of the points. I'm going to use the second one. And I'm going to plug in for y, -4, for x, 2, and I'm going to solve for b. So that would be -4 equals 4/3 plus b. And then I would subtract this 4/3. You do this, you just need to get a common denominator. So -4 is -12/3, and I'm subtracting 4/3 from that. It's going to be -16/3. So I'm going to get the b is -16/3. And so that means that my equation is y equals 2/3 x minus 16/3. Number 22, find an equation of the line that passes through the point 17 and is perpendicular to this line. Well, this line, I need to get it in slope-intercept form. So I'm going to add the 3y to the right side and then divide everything by 3. 1 there. So I would get y equals 1/3 x. It doesn't really matter what the y-intercept is, but plus 16/3. When we do perpendicular, we take the slope and we do the opposite reciprocal. So I know that the slope that I want to use is flip that and make it negative. So I want to use a slope of -3. And it needs to go through this point. So I'm going to, at that point, kind of just go through the process like what I did over here. I would have y equals mx plus b. So I would do y equals -3x plus b. I'm going to plug in 7 for y, 1 for x. That's going to be 7 equals -3 plus b. Add the 3 over. 10 equals b, which means we have y equals -3x plus 10. And the last question is also just a slope-intercept form question. And I know that because it tells me that I see the word linear in this. This guy's hired by an accounting firm. His starting salary is $60,000, and 3 years later, his salary is now $70,500, and we want to assume his salary increases linearly. The first question is to find the equation that relates his annual salary S to the number of years T that he's working. So basically, instead of y equals mx plus b, it's asking you to do like S equals mt plus b, but it's still y equals mx plus b. So for part A, his salary as a function of t is the slope, which is, the way I would find the slope is his salary increased $10,500 over a span of 3 years. So what I would do is I would take his, to find the slope, take his change in salary, again, $10,500, and divide by 3, and that would give me $3,500. That's going to be the slope times t, and then plus his starting salary, which is $60,000. So that's essentially my y equals mx plus b for that. B is just asking what the slope and the s-intercept represent. S-intercept like the y-intercept. The slope, 3,500. That would be his annual increase in salary. Okay, so you just want to write that out. That would be his, how much his salary goes up each year. And then the s-intercept would be his starting salary. Okay. For part C, what will his annual salary be after 12 years with the firm? That means we just want to plug in 12 for t. So we're going to do 3,500 times 12 plus 60,000. And I'm going to go to Desmos to do that. 3,500 times 12 plus 60,000 gives me 102,000. That is his salary after 12 years, 112,000. could have a question instead of after 12 years, it could say if his salary is $102,000, how many years has he been with the firm? In which case you would set this equal to $102,000 and solve for time, and you would find that would be 12. Okay, so a lot of stuff there in the second video, lines, inequalities, equations. That sounds like it's not a whole lot, but there are lots of different kinds of equations and inequalities that you do need to make sure you understand how to go about each one of those.